Two important uses of completing the square are solving quadratic equations and graphing quadratic equations. There's a little bit of difference when we complete the square, so we'll go through an example of each. Okay, the first one we want to solve this. Now it's much easier to complete the square when the coefficient of your x squared is 1. So let's divide everything by 3. The next step, we're going to get rid of this constant, so we're going to subtract 5/3 from both sides. And we're also going to add the number that will make the right hand side a perfect square. To do that, you take half of your coefficient of x, so -3/2, and square that, so we'll get a positive 9/4. And if I add something to the right hand side of the equation, I need to add it to the left hand side. Okay, let's add these fractions. We go off to the side. Our common denominator will be 12, so we're going to have -5/3 times 4/4 plus 9/4 times 3/3, so we'll have -20/12 plus 27/12, which is 7/12. So we have 7/12 equals x minus 3/2 squared. Now we take the square root of both sides. Remember, you need a plus or minus. We'll add 3/2 to both sides. So we're going to have x equals 3/2 plus or minus. Let's split up the square root of 7/12 into square root of 7 over square root of 12. Square root of 12, 12 is 4 times 3, so we can pull out the 2. Square root of 4 is 2. And let's rationalize this denominator by multiplying by √3 over √3. So we'll have the square root of 21 over 2 times 3, which is 6. Let's graph a quadratic equation by completing the square. Our goal is to put the equation into this form because we can easily read off what our vertex is, and we'll know how much it's being stretched vertically or compressed. So first thing, let's pull out the 3 out of all the x terms. So we have x squared minus 3x plus 5. That tells us our a is 3. Now we'll complete the square inside of the parentheses. So we have x squared, half of 3 is 3/2. Square that, you get 9/4. Okay. Now I can't just up and add a number to one side of the equation. So what I'll do is subtract that same number on the same side. So really I'm adding 0. 3 times 9/4 is 27/4. That's how much I added. So I need to subtract 27/4. Now we'll factor this into our perfect square. And 5 is 20 over 4, so we'll end up with -7/4. Now it's in this form. Our vertex is 3/2, -7/4. We're ready to graph it. So here's 3/2, here's -7/4. Our y-intercept from up here is the 5. Can get that by plugging 0 in for x. Now this 3 tells us that we're vertically stretching the graph by a factor of 3. So x squared, from the vertex usually you'll go over 1, up 1. But since we're stretching by 3, we're going to go over 1 and then up 3. There it is.